talk special right triangles. Yesterday we discussed 45, 45, 90s, and we learned that in a 45, 90 or 45, 45, 90 relationship, that if we want to find anything, we know that the hypotenuse is the leg root 2. So that's what we learned yesterday, right? So we're going to do that same concept here, but this time it's going to be with 30, 60, 90. So there's two different triangles you guys need to know how to do. 45, 45, 90s and 30, 60, 90s. Next week on Tuesday, I won't see you guys because you'll be at the scheduling meeting on Tuesday. So originally that meant that you guys we would have reviewed both of these things on Tuesday. You had a worksheet to work on. And then you guys would have taken a quiz at the beginning of class Wednesday before I gave you the next lesson. But since you guys have that assembly, you guys don't have that review day. So what I'm going to do instead is give you guys the quiz on Friday, and on Wednesday and Thursday I'll do like problem of the days or like warm-ups at the beginning of class to practice those skills with you, and you guys won't have your quiz until Friday. My other classes will still, however, have their quiz before you, just so you're aware. But they have that extra work day that you guys don't have. Does everybody understand that? Okay, so don't get scared that yours is on Wednesday, because that's not how it's going to be. So let's determine the relationship of a 30, 60, 90. Do you need me to go back?
No.
Okay. Given each equilateral triangle, draw and label a perpendicular bisector PS, then find the following measurements. So we're going to draw the perpendicular bisector PS. So that's PS there, perpendicular. It's a bisector, which means it splits the angle into two congruent pieces. So now we have a 30, 60, 90, and another 30, 60, 90. If this is an equilateral triangle, originally, do you see the original triangles are equilateral? And this side is 10, what do we know about this side? It's 10. What do we know about this whole side? 10. So if this side is 10 and we just perpendicular bisected it, what do we know about each of these pieces here? They are both 5. Okay, so we have that information. So we have two pieces of information in a right triangle, which means we now can use the Pythagorean theorem to find the height of that triangle. So I'm going to do 5 squared plus x squared equals 10 squared. This is not in context. We have to get a radical solution that is simplified. So it's an equilateral triangle originally, so all of these sides are 10. So since this is a perpendicular bisector, it splits 10 in half. So that's why it's 5 and 5. This is an S here. Those are 5, sorry. You love this? That's awesome. Yeah.
So in these ones we can't use our calculator for it. We have to do the same.
You're not going to be doing the Pythagorean theorem, so you won't need your calculator for this quiz. You won't even be allowed to use your calculator for this quiz, because we're going to come up with another relationship like we came up with on yesterday. So the measure of angle PSR is 90 degrees, because it's a perpendicular bisector. SPR, we said because this splits the angle, is 30. The length of, where's SR? SR, we said, is splits 10 in half, so it's 5. And our height here is 5 root 3. No, and you won't need to. Think about the worksheet yesterday. Did you really need to use your calculator? No. It's like that. We're going to come up with another relationship. You won't be using the Pythagorean theorem. Okay? Okay, so let's do the same thing on this one. Since this is equilateral, all the sides are 2. We're dropping that perpendicular bisector again. Right, so it means that both of those pieces are what, Rob, on the bottom?
1.
1 and 1, because it splits the 2 in half.
Oh, shoot. Am I understanding this? I've understood this.
It also splits this angle in half, so those are both 30. So we can do the Pythagorean theorem here. Is that better? I made the one a little bit taller so that it wasn't... I just love the conversation you're having with yourself right now. Sorry. No, and I appreciate it, and that's why I'm not telling you to stop, because I think it's helping you. So PSR is a 90-degree angle. SPR is a 30-degree angle. SR, as Rob told us, was 1, and we found PS to be the root of 3. So what do you guys notice about these relationships? So first of all, let's look at the one opposite the 30-degree angle, and this one is 5. Opposite the 30-degree angle, and this one is 1. Opposite the 60-degree angle, and this one is 5 root 3. Opposite the 60-degree angle, and this one is 1 root 3. What do you notice about the one opposite the 60? 5 root 3. 1 root 3. It's always like, okay, so we have a short leg.
I don't know how to say it, but like I know like what you're saying.
So we have a short leg, which is the smallest side. That's the one opposite the 30-degree angle. So to get to the middle leg is what I'm going to call it. So root 3. You take the short leg. Oh, that's the long leg because it's a leg, sorry. So you take, to get the long leg, you take the short leg, root 3. Do you see how this is a leg and this is a leg here? Even though Rob hates that. But this is a leg and this is a leg. Didn't you tell me that yesterday that you didn't understand why they were called legs? Is that you?
You said this one was a leg.
I said these two are legs. And you were like, why is that one called the leg? You said something about being the bottom or whatever like that.
Yeah, that's like the base. That should just
Yeah,
be like the
well,
floor.
they call it the legs. That's what you said.
Wait, I thought
So-
the legs were
So to get the long leg, you take the short leg, radical 3. Okay? What do you notice about the relationship of the short leg and the hypotenuse? So the short leg is half the hypotenuse, or you can take the short leg times 2 and get the hypotenuse. So both of you guys said halving it, which is the same thing as what I'm writing here, just the opposite way. So to get the hypotenuse, you take the shortest leg and you multiply it by 2. This is the relationship we will be using on this one. So we have the 45, 45, 90 triangle, that's n root 2. Our 30, 60, 90 triangle is S. You don't have to, you could use n, s, it doesn't matter. It's going to be s root 3, and 2s. So the length of the hypotenuse is double the length of the shorter leg. The length of the long leg is radical 3 times the length of the shorter leg, is what we just discovered. So this beautiful triangle here is the other one you have to memorize. So 45, 45, 90 is n root 3, or n root 2, sorry. n root 2, sorry. And the 30, 60, 90, do you see how there's a 3 in the 30, 60, 90? Is S, S root 3, and 2S. So that's why you're doing a root 3 instead. And then now Rob is not very happy anymore.
So this one's S.
You could use ends. Did you like the ends better?
Yeah.
Do you guys want to use ends on both of them?
No, I just said S.
You prefer, it doesn't, do you like that they're different?
No, I like that they're different because then I can.
So it helps that it's different. Casey, if you like ends better, look at me. If you like ends better, just change all these S's to ends. It's the same thing, okay? But if you like it to be separate, use different letters. Do you guys understand that?
What does it mean by the leg of the hypotenuse is double?
That means that the length of the hypotenuse, so the longest side,
So the 2S.
is double the shortest side.
Okay.
Okay.
That's why it's 2S, because you're doubling the short side. Does that make sense?
Yeah.
Just 1 second. This is a little bit more work, guys. It's because it's you don't know two sides right off the bat, like 45, 45, 90s. Yeah.
Can I come in Tuesday? Can you like reteach the thing?
Yes.
Because
I know. I figured you would be.
I'm kind of there.
That's good.
I wasn't here.
Yeah, you're going to be lost if you weren't here.
I'm not talking bad about it.
Is this the next slide, or did I skip a slide?
Skipped over a slide.
Is this it?
Yes.
Okay. So it's a 30, 60, 90. Opposite the 30 is S. Opposite the 60 is S root 3. And opposite the 90 is 2S. So the first thing we always do is label our sides. So Morgan, opposite the 30 should be S. Good. Kylie, opposite the 60, which is this angle here, should be
S.
good. And Rob, opposite the 90 is, I'm going to say 2S, the same thing you said though. If two things are on the same side, we know they are congruent or equal because they're the same length. You'll always put the number in front of the variable. That's why. So we already know what S is. Isn't S already solved for in this one for us? What is S? So that means wherever we see an S, that's an S. This is why I hate S's. Wherever we see an S, we can plug in an 8. Lindsay, just try to catch up here, though, because it will help for when I reteach the other lesson to you. Okay? So this is going to be 8 root 3 equals X, because we replaced S with 8. And we're going to do 2 times 8, which is 16, so that is Y. So if you're given the short side, it's the easiest because you can just plug it in.
So that's the answer?
Those are your answers. The ones that I have boxed there. So I can rewrite them underneath too if that makes it easier for you to see them. This is why you don't need a calculator. Yeah, so this one's a little bit different, isn't it? So, Greg, opposite the 30, we put what?
S.
Not a 5, not a 25, right? It's an S. I'm sorry, guys. So, opposite the 60, Logan, is what? Perfect. And then, Jill, opposite the 90 is? So, we set all of them equal. I forgot the 2. Because if they're on the same side, they're the same length, and if two things are the same in math, they are equal. So, S is the same thing as Y. Does that help us out very much? Can we solve and get anything? No, we have 2 unknowns. How about S root 3 equals X? Can we solve anything there? No, we have 2 unknowns. How about 14 equals 2S? How many unknowns are in that statement? 1. So we can solve that one. So I'm going to write 14 equals 2S. Divide by 2, so that makes S 7. Do not change side lengths. What is the length of this side? 14. It is not 7. Please do not tell me that one is 7. Which one of those lengths is 7? the length of y. So y equals 7, because wherever we see an s now, we can replace it with 7. So Rob, what is x then?
7 root 3.
Perfect.
I don't know what happened.
Oh, yeah.
Probably because you already understand the concept from yesterday. You know what I mean? It's the same concept, just different numbers now.
I didn't understand.
Do you get what I'm saying? But you might get it now. Because it's that same concept now, but with different, like with a different thing. I think if you're going back.
I don't ever understand math, and I'm really shocked.
I'm very happy that you're understanding. It's making me happy, so please. Okay. Daniel, opposite the 30, we write a... Oh. Be careful. Opposite the 30 is just S. Cameron. It's the one that's not labeled, because if this is... So if you think about this, Casey, because that's a good point you're bringing up. 90 plus 60 is 150, so that forces this one to be 30. Does that make sense? Cameron, opposite the 60 is... What do we label opposite 60s? Opposite a 60-degree angle is... Not to the power of 3, that's a radical. So that's S root 3. 1 second. Opposite the 90 is what, Emma? Good. What's up, Jill? Do I just call you Jill? Sorry. Oh my gosh. Lindsay.
Oh, I was going to, but also I have a question. So if it's like between the 90 and the 30, is it always going to be S? And if it's like between the 60 and the 90, it's S, and then like the 60.
Right, because that makes it the one that's opposite. So if you want to think of it this way, I think of it like what side it's opposite of. So like the 30-degree angle is there, so that's the one that's opposite. But what you're saying is true too. Okay, let's think about this. Can you solve this one? How many unknowns are there?
No.
2. How many unknowns are here? How many unknowns are on this one? 1. This is like the radical 2 side from yesterday. So we have S radical 3. Carmichael, what do I do to get S alone? We're going to divide. I heard that word. So Carmichael, tell me, what are we going to divide by? Nope, 6 is already alone. We want to get S alone. S is what we're trying to get alone. Your last option, radical 3. So we're trying to get S alone, which means that we have to divide by radical 3. It's weird to divide by a radical. I think that's why you guys don't want to say it. But it is what you're dividing by. So that cancels there. We have to rationalize because we can't have a radical in the denominator. So I have 6 square root of 3 over the square root of 9. These are the ones you don't like. I think that's why you didn't like yesterday, because there's radicals in it. So just pay attention to these ones and try to figure, see if this part can click for you today, okay? So radical 3 has a group of 2 3s, or radical 9 does, I'm sorry. So that makes that 3. So 6 divided by 3 is 2. So this is 2 radical 3 is S. So wherever we see an S, we can take this and replace that S with 2 radical 3. So EQX is 2 radical 3. How about the side that's 2S? How would I do that, Hayden? What would you do, Hayden, to do 2S? Yep, you multiply the 2 by 2, which is 4 radical 3. It clicked? Are you okay, Casey? Do you need me to slow down?
Like, it's clicking, but it's still kind of like...
Why is this happening?
Yeah.
It's just all of this relationship.
Mine's like reason.
What's up?
So, how did you get down to
2 radical 3.
So, do you understand the rationalizing part?
Yeah.
So, I did a factor tree for 9.
Yeah, to
And
make it over 3.
3. And this is still 6 here. Is that what yours says there?
Mine says 2.
That would still be a 6 there. So it'd be 6 radical 3 over 3.
Okay.
So 6 divided by 3 is
2.
2. So that's where it came from. Does that make sense?
Also, like, when you do something like,
All right.
or like check something off, like it really takes like chemical and like.
Abby, opposite the 30 I label Good. Gabe, opposite the 60 I label Yep.
Dude, I love math.
What radical 3?
Dude, I love math.
I'm so glad. It was a good broken.
No.
Austin, opposite the 90. I know it's not labeled, but this is forced to be 90. So Austin, opposite the 90 is? Two things are the same. We can set them equal. So, do we solve for the one opposite the 30, the 60, or the 90 in this case?
60.
Opposite the 60. It's the only one that has one unknown. And if you divide both sides by radical 3, what cancels out on both sides? The radical 3. So we're stuck with S's. So radical 3 divided by radical 3 is 1.
Oh, you skipped this one.
Did I skip a slide again?
Yeah.
Oh,
Don't say anything. We're hoping to get
I'm not going to go back.
something.
I'm not going to go back. These are all good problems. It doesn't matter. So
Oh, I was just.
you're just confused. I didn't even know I skipped a slide. It's fine. I don't think we're going to get through all of them anyways. It's already 9:18. Okay, so S is the same as 3. So wherever we see an S, we can replace it with 3. Exactly, Rob. Mm-hmm. Yep. So Y equals 3. Then we do 2 times 3 for X. So X equals 6.
What the heck happened to me? This is weird.
I don't care if you put them off to the side or they're just on the correct side. Either or is fine for me. It's nice to understand because you don't feel like you want to go crawl in a hole somewhere and just be like, I'm done. You know what I mean?
I bet you rub it in. Also, I'm not trying to rub it in anyone's face who's like not understanding, but because like I never understood anything, so like now I do.
It just makes you, when you're more confident, it makes things easier to learn. If you're not as confident, it makes it very hard to learn something. So,
Why do you hate that so much?
I don't know, it just annoys me.
Just saying, yeah.
Yeah.
Robert. So we have S root 3, and 2S. Anybody confused on those labels up there? Okay, Desiree, which side am I going to have to solve? The 30, 60, or 90? Yes, it's the only one, sorry. This class gets really excited about knowing answers and they just shout things out. But it's the only one that doesn't have 2 unknowns. So we do 2S equals 11, and we're going to leave this as a fraction of 11 over 2. You all have a beautiful fraction button on your calculators that you should love. I know, but it won't matter. I'm telling you right now, it won't matter. So, I'm not lying. What? Because you shouldn't have a decimal in front of a radical. Mathematically, that's not okay. I mean, honestly, if you wrote that, would I get that mad? No, but it's just not mathematically correct, so it makes me cringe a little bit.
Okay, no, you yell if you saw that. You'd be like,
Wait.
Lindsay, why would you do such a thing?
okay, so
11 over 2 root 3.
Yeah, so this one is 11 over 2. X is 11 over 2, and then the other one is 11 over 2 root 3. So that is 11, and you can write it like this. Or you can write it like this. Or you can write it like this. Whoa. We can go backwards, people. This iPad goes backwards. I never said I wasn't going back. I said I didn't know if we'd have time to go back.
You said we were not doing that slide.
said we're not going back.
Are you recording? We can listen to you say that.
That's true, I am recording. Actually, this side is super easy anyways because it's all opposite the 30. So this is like a 3, so this would be 3 root 3 and 6. You know what I mean? It's easy already. We're done.
Thank you. Now you're